project. Okay, so we're gonna jump right back in. Make sure you have your calculators ready to go. And no, there was no homework, right? But after today, you will have a little bit to do. Okay. Forgot names already. Diane, right? Could you turn off the front lights for me? Thank you. Perfect. By the way, I'm going to ask you almost every day to do that. I hope you're okay. All right, so we did a bunch of conversions, and the key here was to make sure the units are on like either numerator or denominator so that they cancel out, right? So that was a nice little review. Final answers always get rounded to 2 decimals. As we work, we basically use all decimals because you have these calculators. You can always copy the previous entry and keep going with it, right? But let's turn up the heat a little bit. You will be asked to convert units for 2-dimensional areas, areas, and 3-dimensional measurements, which we call volumes, right? You may use the rates given above, but remember that the units must be squared or cubed. I will also take this opportunity to remind you that these rates should probably be on your study sheet. Try to compress them as much as you can, okay? And I'm just looking at one that is an easy one to also say that 1 mile has this many kilometers, but it also has this many meters. I don't know if you want to add that to your notes real quick, right? Because there's 1,000 meters in a kilometer, so we can go ahead and say this as well, right? All right, so halfway down, let's do some conversions here. So I ultimately want to tell you that 1 square meter has 10,000 centimeters squared. Go ahead and write that down. 1 square meter has 10,000 squared centimeters. And how is that? How is that? Well, if 1 meter has 100 centimeters, that's how we start. That's where the logic starts. If you were to take this whole equation and you square it, I hope I'm not scaring you with this, right? But then you know that 1 square meter, right? 1 squared is just 1. Meter squared, we just write it like that. Grab your calculator for a moment here. I want to, at the same time, show you how to use your calculator, okay? So if you turn it on, am I recording this? Yeah, I am. You will tell me if I'm not, right? Somebody has to tell me something because at times I forget. Press mode real quick. Or did I do this already on Wednesday? I may have done this on Wednesday. I forget. And this is where I'm going to have a different calculator for you guys. I will do that right now because I do 11 applied and 12 applied, and I will mix them up. So we want it like this. If you press mode, you want to have all the settings set to whatever the dark section is. So I want you to really quickly just check to make sure those are your settings so that we don't have any problems down the road. Okay, and this is what some of you might have this where it's set to degrees. So if you hit enter, bottom right is enter. If it's set to degrees, you need to make sure you go over to the left to radians and turn it to radians. You can't have it in degrees because later on when we do sine and cosine, like we need it to radians. Okay. And I have stat diagnostics. I will have that off. And the stat wizard, I think I want the stat wizard, the Wizard of Oz. I want that off, right? I don't want the wizard because it actually it looks different when you have the wizard. So stat wizard, I would turn it off, okay? And then again, at any moment, if you're like, I don't get it, I'm getting this issue on my calculator, I'm getting an error, let me know. I'm here to help you, okay? How do you go to your home screen? second mode, right? If you press second, as soon as you press second, it's like your shift button on a, and there should be an arrow pointing up as soon as you press shift, right? Either there or it'll be at the very top of your screen. But anyways, second mode gets you back to the home screen. Clear clears the whole screen. And delete, which is right here, delete is right here. It just deletes the one thing you wanted to get rid of. And you're like, I know this already. Well, just making sure. Okay, so 100 squared, you have two options, guys. There's the X2 button right here on the left. That's the easiest, quickest way of squaring something. And then you get 10,000. Or this is the other one, because you're going to need to know this one. 100, and then you see that hat button right here. My finger is right on it. The hat button, you see that? If you press the hat button, it goes to the exponent, and you can type in any exponent you would like. So if you want squared, then you hit enter, and it does the same thing. I need to warn you though. Let's say it's 100 squared, so I'm going to use the hat button plus 5,000. Watch what happens. Plus 5,000. Is that where you want the plus 5,000? No. So I'm going to delete all of that. You need to go arrow sideways for the cursor to come back down. It's a frustrating little nuance, but you need to make sure you know that, right? And then you go plus 5,000, and it does everything you want it to do, okay? And more, we will learn more as we go. Anyways, so we know that. Oh, okay. Thought you said what? Say what? So when you square the whole thing, I'm going ahead and squaring everything, and that's where that comes from. Sorry. I need to learn how to use my camera here. So if I square the whole thing, I'm squaring everything individually, and I end up with 100 squared, right? And that's where I get the 10,000 from. So 1 square meter has 10,000 square centimeters. Does that make sense? And sometimes it doesn't. So if you just go 1 meter has 100 centimeters, right? But when you're talking a square meter, you're actually talking about a square that measures 1 meter by 1 meter. And so in here, if you were to draw little square centimeters, you would be able to fill in 10,000 square centimeters because it's 100 centimeters by 100 centimeters, right? So you're talking completely different units, right? When you're doing squared units. So, Mr. Dirksen, can I, from now on, just stick with this fact? Absolutely, but I need you to know how I got there. I don't want to just give you everything without thinking it through. A square foot, how many square inches would it have? Focus on feet and inches. I know that 1 foot has 12 inches. But I need it in squared units. So if I square the whole thing, I get 1 square foot. 12 times 12 is 144 squared inches. So now I just gave you a new rate here. 1 square foot has, so if you want to add those that I'm circling to your study sheet, go for it. Yards and feet. This one is going to be very popular, by the way. 1 yard has how many feet? You go up there, you check. I hope I gave you that. Yeah, 3 feet, right there. You see 1 yard, 3 feet? You see that? So 1 yard has 3 feet. What units am I now dealing with? Cubic units. Okay, so I got to cube everything. So that's 1 cubic yard is 3 cubed cubic feet. And I know some of you are like, what's happening here, Mr. Dirksen? I've never seen this before. Well, this is somewhat of a new concept, right? What's 3 cubed? It's 3 times 3 times 3, which is 27 cubic feet. So that's where you get the 27 from. cubic meters to cubic yards. Not so popular, this one, but it's still the same idea. You start with 1 meter has how many yards? Let's go up there. Oh, I didn't do that, did I? I gave you that 1 yard has 0.91. I'll fix that. Hold on. One meter is 1.0936 of a yard. Don't worry about it too much. It's not in your thing. Don't worry about this one. I just wanted to do one more. So we're going to cube the whole thing. So it's 1 cubic meter. If I go 1.0936 to the power of 3, watch how I'm going to do this on my calculator. To the power of 3. You go ahead and do that just to go through. That's 1.3079 cubic yards. If you remember, like, it's not going to take up too much space on your study sheet, but if you don't want to do this one, it's okay. Like, if you don't want to add this to your study sheet, I'm fine with that. Okay. Note, some students prefer to convert all dimensions given individually, then proceed to find the final area or volume. Just make sure you do not round along the way. So this is what I mean, okay? It could be that I give you the dimensions of a rectangular box in inches, and I ask you to give me the final answer in cubic feet. So a lot of students will be like, well, I'm going to convert all of my dimensions to feet right away, and then I will proceed to find the volume, right, in the units that you want me to have them in. You just have to be careful that you don't round too soon along the way. I personally will most likely just find the volume or area and then convert at the end. That's what I will do, okay? So here we go. A circle has a radius of 9 inches. Calculate the area in square feet. This is where calculator is going to be. I'm going to show you how to use pi and all of those things. So the area of a circle is pi times radius squared. I'm going to go area of a circle is pi times 9 inches squared. Okay. Remember diameter and radius, right? Diameter is 2 times the radius. So just make sure you divide it in half if that happens. So here's where I'm going to ask you to do this. Grab your calculator real quick. I'm going to clear my screen. And I'm going to call pi. This is how you do it. Anything in blue, like if you look at pi, it's right here above the hat. That's pi, so you got to press second and then that button to call pi, see? So you go pi, I want you to use pi. I don't want you to use 3.1415, right? I want you to use all the decimals, times 9 squared. I'm going to go x2 like that. So that gives you 254.469 dot dot dot. And what units am I in? Squared inches. Why am I not rounding? Because this is not my final answer. I'm not there yet. It's asking in square feet. Okay, so watch this. And I'm going to multiply this by something that I already know. You see this one here? 1 square feet has 144 squared inches. I'm going to put the 144 squared inches down here and know that that is the equivalent of 1 square foot. And I remember I told you I really like highlighters. I just want to show that these units will cancel out. And that really you're going to take this number and you're going to divide it by 144. Okay? So you remember how to do that on the calculator? So I'm going to call my last answer. Sorry, I'm going to move that a bit. I'm going to call that last answer divided by 144, and that's 1.77. Now you can round, okay? 1.77 square feet. So you would get 1 mark to get to here, and then another mark for actually doing the proper conversion, okay? So I can see that some of you will go ahead and turn the 9 inches to feet and then go ahead with this. That's fine. Okay, that is fine. All right, let's keep going. We're going to slowly up the difficulty level. A box measures this times this times. So by definition, it'll be length, width, and height. Not that it really matters, but length, width, height is by default, not by definition. By default, that's how we do it. Determine the volume of the box in cubic meters. Right? So the volume, so volume of a box is length times width times height. So that would be 24.6 times 20.4 times 34.7. So I'm going to go ahead and do that. Every once in a while, I'm going to make mistakes, okay? Right, folks? Every once in a while, those that know me, it's not all the time, I hope, but that's just part of teaching, right? I am a human being. I also get butterflies when I have to teach, and I do make mistakes, okay? What units am I in? Volume, yeah, but inches, cube. So I should have done that, but I should have actually put in inches here, inches there, because you're also always multiplying the units, whether you think of it or not, you are doing that. So we're in inches cubed. That's not where we want to be. We want to be in cubic meters, so I'm going to go ahead and do that. How would I do that, though? I'm going to go find something that's going to help me. So inches to meters. Let me see. I have inches to centimeters, right? And I will give you a cheat here. Okay. Can I turn the centimeters to meters? What do I need to divide it by? 100. Write that down. It's just dividing it by 100. So an inch, I can't do everything. I can't write everything down, right? So every once in a while, I'll just give you a little trick, right? So I'm going to remember that 0.0254. 0.0254, okay. 1 inch is 0.0254 meters. Phew, I got that. I'm good. Can I just go ahead and convert now? No, right? And you're thinking, why not? Cubic inches, this is just inches to meters. So what do I need to do to this whole thing? Cube the whole thing. Cube the whole thing. So this is 17413.848 cubic inches times 1 cubic inch. And let's figure out what that is. 0.0254 to the power of 3. Are you familiar with that? I was hoping that wasn't going to be the problem. Are you familiar with scientific notation when you have that? That's basically saying shift the decimal over five decimal places to the left. So what I'm going to do here, I don't like that too much. I don't like, we don't do learning curve. The other calculators, they don't give me that. What was the trick? I remember there was a trick that I did. Anyway, so what we're going to do here is this. You write down 1.63, you keep going, but you have to shift this over 5 places. 1, 2, 3, 4, 5. You put the decimal right there. Because this is e to the negative 5, right? Write that down as well. So we shift 1, 2, 3, 4, 5. You put the decimal right there, and the valleys that you've created, you fill them in with zeros. I'll show you a way around it in a bit, where you don't have to worry if you don't get this part. You should, because if you take chemistry or anything like that, you bet that you will have this. You'll have to use scientific notation. So what we need to do here is now we go to our calculator, and even though it's in scientific notation, it doesn't matter. I'm gonna go up and grab this number, gonna copy it, then I'm gonna go times the one I just got, the weird one there, enter, right? So it's gonna copy, so it's gonna multiply the two, and that's gonna solve the problem. So I'm gonna cancel the cubic units here, and I'm gonna go 0.29285, right, which rounds to 29 cubic meters. That's the volume of that box in cubic meters. Okay. So, Mr. Dirksen, what if I wrote this down in scientific notation? Would you mark that wrong? I don't think so. I think I'll be okay with it. But really, you should be writing it like this then, 1.638 times 10 to the negative 5. That's what this is really saying here. Right? I'm going to try to avoid those, but I'm not going to promise. I'm not going to make any promises. Okay. Convert the following. So we're going to do a little bit of converting here. I want you to try to convert between these units, and I will do my attendance. Okay. So you give this a try. Remember, this is where you try with the best you can to convert, and then I will go over it, and then we'll continue with our next section. Okay. Then I get how much millimeters. So you know if I times it, I did that wrong. Yeah, I did that wrong. Then How are we doing with the first one? I used all decimals, right? On my calculator when I square this. So it's 15.
Okay. And then you multiply it, and then, yeah. Oh, okay.
What about this one?
Yeah, you're getting that right. Wait, can you show the other one again? Thank you.
So I'm using the exact same rate. One needs to be cubed, one needs to be squared, and also the placement of where you put it has everything to do with how you start, because you want to cancel those out.
Yeah, I got 184.1.
Is he brown?
I don't think so. You'll probably just go over it.
Are you ready for this one?
Yeah.
You want to do it first? Okay, just be a bit quieter. Okay, I'm gonna hold it for a bit, but I'm gonna get going because I want to get to the other part. This is just what's going to be required of you here and there to convert. Some of you got clever here, and I like that. Some of you said, hey, if 1 inch is this many centimeters, 1 centimeter has how many millimeters? 10. Can I just multiply this by 10? Yeah, so cheat. I'm going to do the little cheat code here. I'm going to do this. 1 inch has 2540 millimeters, correct? Like, I want you to start thinking like that if you can. If you did this in steps, I will actually now do it in steps, but if you don't, then hey, this is another one that is going to make it a little bit faster. That's where your study sheet, if you have a robust study sheet, you're going to be more efficient, okay? You don't have to memorize. Oh, yeah. I went times 100, didn't I? 25.4. 25.40, 25.4, same thing. My bad. I told you I make mistakes here and there. Thank you, Robert, for catching it. 25.4, yeah, that's right. Okay, I'm going to go over here. And so I know that this is true, so I'm going to square that. But this is also true. I need to go from 1 centimeter has how many millimeters? I also need to square that. You need to square everything because otherwise you're not canceling out the same units, okay? So it's 2850 squared inches times, and I'm actually going to go through the whole process here just so you see it. I'm not always going to do that, but 6.4516 over 1 squared inch, right? And this is now squared centimeters. This cancels out with that. And then I will go, that's 100, right? Millimeters squared over 1 centimeter squared. And the centimeters cancels out here, right? Cancel, cancel. So now I'm just going to go ahead and go 2850 times 6. Oh, I have that answer. Why would I type it in again? I forget that I have this calculator. Times 100. I don't need to worry about the denominator because it's just 1. So that is 1838706. And that is millimeters squared. That's my final answer. Those of you that did it in one step, same thing, right? You got the same thing? Hopefully, it should, right? Okay, next. I think I'm going to skip that one. You did it? Okay. So I'm going to go volume is 9 times 12 times 20. So that would be 2160. Centimeters what? Cube, right? And I need to convert it. So I'm going to go times 1 inch has 2.54 centimeters. I need to cube this, and I will allow you to skip this step down the road. So if you just want to go 2160 divided by 2.54 cubed, correct? If you want to do it that way, you have to be careful, but it can be done. Right? So you get, yeah. Oh, sorry. I have to relearn how to use this properly, obviously, right? Sorry about that. So I have to cube this, and I get 131.81 I am in cubic inches. Voila, right? When I make these booklets, I work everything out on loose leaf, so I make sure it works out, but then I don't have all the neat answers. Yeah.
Are we going to get marks to the if we just go straight to the answer like that?
If you get it wrong, then you will lose more than if you show me all the steps in between. So you kind of have to see how comfortable you are with that. To be honest, I would say at first maybe, because most questions are going to be like this, it's just one conversion. So it's not like you're going to have to do like 2 or 3 or 4 different steps. So I would say, just say show your work. All right, keep going. Next page, page 3. Some of these formulas, you're going to be like, I know them, don't need to worry about them. Pay attention as to what I do with the formulas. And I refer to certain sections. And that's because we're going to use this for word problems. You need to know what each part of the formula does. Okay? You ready? In this section, we will review the formulas of the most common prisms. Right? It is very important to understand how the formulas are deducted. Right? I will make sure you know. And how they would be affected if a face or multiple faces were to be removed or omitted. Remember you did surface areas and volumes in IAPR and Intro to Applied? That it's coming back now, big time. Remember that ultimately these skills will be used to solve word problems. Okay. So surface area, if you ever see SA, it refers to surface area. And it's basically determine the amount of material needed to cover or construct something. So it could be cardboard, fabric, sheet metal, you name it, that you need to cover something with, or you need that to construct it. So paint, tiles, carpet. You're like carpet, right? You're covering something with carpet. Amount of metal needed to construct, right? Metal needed to construct the faces and so forth. So it's very important that you know that, because down the road, I will ask you, calculate the cost to cover something in carpet, to lay down the carpet. You're going to be like, oh yeah, that's area or surface area. Lateral surface area, LSA, it's lateral surface area. It is the area of the sides only. Top and bottom are not included. Okay. In some instances, you will need to omit the ceiling and floor, especially when you're painting a room, right? Most of the time, we don't paint the ceiling and we don't paint the floor. So we just look at the lateral surface area. V obviously stands for volume. Calculated when the question is concerned, right? You want to determine the amount of material needed to fill or empty an object. So when you're digging out, if you build a swimming pool, right, when they dig out soil, right, they're digging out maybe a rectangular box or whatever to then later fill it with water, right, or something like that. So we could ask you concrete needed to pour a sidewalk, amount of soil that needs to be removed to build a pool, how much water you can fit in a fish tank, you name it. Note, by definition, the volume of a prism, this is very important, the volume of a prism is area of base times the height. And on Monday, I will try to have my other software open where I show you, right? If you think about it, if this is the base here, the area of the base, if you multiply it by the height, that's the volume, right? It's like how many sheets of that face can you stack to fill that object, right? So volume of a prism is area of base times the height. That's by definition. And I'm going to draw from that later on as we go. Okay. Okay, so if you're given a rectangular prism, that's the most common, we're most familiar with. The surface area is 2 times length times width, and so forth, right? I want you to know that this part right here, length times width, right? That is the top and bottom. Right? That's the top and bottom. Width times height. So the width times height is the sides. And the length times height, right? The length times the height is the front and back. Okay. So top and bottom is, this would be the ceiling and the floor. And this would be the sides, basically, of the room. Lateral surface area, therefore, let's do this, 2 times length times width plus 2 times width times height plus 2 times length times height. I want to write the whole thing down, okay? If you want the lateral surface area, which one of these expressions will go? Which ones will we scratch? Top and bottom, which is length and width. And this is another way of thinking about it. It's the only one that doesn't include the height, because if you include the height, right, the sides of the room includes the height. Right? These are the only two expressions that have a height, so these are the sides. Right? So lateral surface area is 2 times width times height plus 2 times length times height. What if, though, sometimes we do paint the ceiling, right? Every once in a while, the ceiling needs to be painted. So if it's lateral surface area and ceiling, let's write out the whole thing again. Trust me, I need you to do this. I know you get it already, right? But Remember, you only learn math by doing math. Same thing, when you write stuff down, you're kind of like, okay, got it. If you want the ceiling, that means that you're going to want at least one expression, one length times width, correct? So I'm going to use my red pen here. I'm going to cross this out and just go 1. Okay? So it turns out to be length times width, like that, plus 2 times length times height, plus 2 times width times height. So no ceiling, no floor, it's just the lateral surface area. If they want the ceiling as well, then you need to have at least one L times W, not two LW, just one LW. We don't bother putting the 1 in front. Okay? Watch this, the note here. Let's talk volume here. Note, usually the formula for the volume is not affected when the side is removed or not visible, because volume, we're more concerned with filling something up. So let's say the fish tank is open at the top, doesn't matter, right? You're still filling it up with the same amount of water. So volume is length times width times height. I want you to know that what's length times width, guys? Length times width is this part right here. It's this face right here. This is the area of the base. You can write that down. And so this is area of the base times height. That's the volume of a prism. By definition is length times width times height. But really the length times width comes from the fact that that is the area of its base. And then multiply it by height. So I don't know, this might be a bit messy, but I will just do it like that. That's a little dark. Darker than I like it, but whatever. Okay. Okay, this is just a rectangular prism. These formulas, these three, let me box that in to make sure, because I told you I'm going to box everything in. Right? Those are probably, unless you understand how that formula works, like I know that me, myself, but I've done this so many times. I can just write down the first one and I know what each expression means. So I'll just adjust it as I need to. But if you need a reminder, then by all means, I'll go for it. Okay. Next page. This is pyramids are, that's the cousin of the rectangular prism actually. So this is page 4. Okay, square base pyramids. We're going to do square base pyramids and rectangular base pyramids maybe later on. But for now, we're just going to stick to square base pyramids because they're a little bit easier to work with, and that's the most common example. So I'm going to deduct the formula with you. Area of the base, surface area would be area of the base plus 4 triangles because there are 4 triangles all around. So area of the base in this case would be a squared, right? Plus 4 times here you have to be very careful. If you look at just one face of this triangle right here, maybe I will do green here. I'm just going to focus in on this one triangle here. All 4 of them are exactly the same. All 4 of them are exactly the same, but the base of this triangle would be A times the height of this triangle, of that face, the triangle that is on this face is called S. Do you remember the slant height? There are 2 different heights when it comes to pyramids and cones. There's the one that's slanted along the face, and then there's the one that we call height that is straight down the center of it. So for this, you need to use the slant, A times S divided by what? 2. A times S, it's base times height divided by 2. There's 4 of those, right? So we can simplify that a little bit. It's A squared plus this 4 and this 2 can simplify. The 2 goes in here 2 times. The 2 goes in here 1 time. So it goes 2 times A times S. That is the formula of the surface area of a square base pyramid. If you only want the lateral surface area, what are you omitting if it's just the sides? The base. It only has a base. It doesn't have a top, right? So we're just going to go 2 times A times S. You guessed it. What's the volume of this? Anybody remember? It's actually the area of the base, right? So it's A times A, which is A squared, times height, the actual height, okay, not the slant height, divided by 3. So the volume actually resorts to A squared times height divided by 3. And you're like, Mr. Dirksen, I thought you always said that the volume is always the area of the base times its height. But there's a problem. The base isn't exactly the same as the top, right? It actually shrinks. So that's why we have to divide it by 3. I will also tell you that some teachers or textbooks may have done this, 1/3 A squared times height. Don't let that throw you off. These are doing the exact same thing. They're just taking the third down here and then put it up front, 1/3. I like to just keep it like this. That's my preference, okay? Oh, it's almost time. I will leave it like that. I will just leave it at that. Come back re-energized because we're going to continue this on Monday. The only homework